Imagine a universe where the silence of space is shattered not by meteor collisions or the whispers of cosmic winds, but by the echoes of war, a battlefield extending across the vacuum where Earth and a rogue moon colony stand at the brink of cosmic catastrophe. As we vault into this deeply intriguing narrative, let's ponder the sophisticated tableau of futuristic warfare, a scenario where technological prowess spells the difference between dominion and destruction. At the heart of this interstellar arsenal are antimatter weapons, the crown jewels of destructive science fiction turned unsettling reality. Picture this, a device so potent that when its contained antimatter meets matter, the resultant energy release is total, absolute, pure E m² in action, energy enough to power or end worlds. The idea of an antimatter bomb held at bay by an electromagnetic field teeters on the edge of awe and terror. Antimatter, the same stuff fueling the engines of the Starship Enterprise in Star Trek, is no longer relegated to the dreams of scriptwriters. Today's researchers are already managing minute amounts at facilities like CERN. Though currently produced in atoms, what happens when we scale up to grams, engineered meticulously for annihilation? Swinging from the minuscule to the massive, let's catapult our imaginations to the kinetic energy projectiles, or the so-called rods from God. Envision telephone pole-sized tungsten rods, dispatched from orbit, harnessing nothing but Earth's own gravity to achieve hypervelocity impacts that could obliterate fortified bunkers or annihilate strategic infrastructures without a trace of fallout. Such unsophisticated yet frighteningly effective tools turn Newton's old adage, "What goes up must come down," into a strategic doctrine of devastating simplicity. However, not all our future weapons emit a bang. Enter laser weapons, rays of coherent light able to travel at 299,792 kilometers per second to precisely strike targets with heat intense enough to cut through steel, disrupt electronics, or incapacitate enemy vessels with surgical accuracy. Here lies a weapon of light, where distance is no shield against its searing touch. The operational use of laser systems, like those being tested by major global powers today, hints at a near future where a flash of light could determine the outcome of a space skirmish. Yet in space, the nuclear option takes on new complexions. Nuclear weapons, devoid of atmospheric interference, won't mushroom, but rather unleash spheres of incendiary radiation and electromagnetic pulses, EMPs, that could cripple electrical systems across vast stretches of space and on terrestrial grounds. Such EMP effects, which might knock out entire grids, turning technological societies back to the Dark Ages, represent a chilling cascade of technological regression initiated from orbits above. Railguns and projectile launch systems push the very limits of our current electromagnetic mastery. These systems, utilizing the same principles that power some of the world's fastest roller coasters, could theoretically send projectiles hurtling towards targets at a fraction of light speed. The sheer velocity attainable could mean that battles across lunar distances might be decided in minutes, if not seconds, as rail-launched payloads deliver their kinetic energy with asteroidal impact. Turning to countermeasures, imagine cloaking devices shrouding spacecraft from enemy sights, akin to the invisibility cloak of Harry Potter fame, but crafted from the fabric of metamaterials that guide radar and light waves away instead of towards. Such sci-fi turned science toolkits could redefine hide and seek at a cosmic scale, placing a premium on sensors and detectors just as much as on the weapons they aim to evade. However, the innovation of tools of war inevitably invites contemplation of their wider impacts. The unique combat environment of space, free from the drag and friction of atmospheres or the moral murk of inhabited battlefields, suggests a purity of engagement but belies the complexities of debris fields in orbit, the potential for mistargeted weapons to continue indefinitely into the void, or the indiscriminate nature of EMPs affecting not just military, but also civilian electronics. Lastly, the ethical and political ramifications spiral outward from the core of conflict. The extension of Earth's geopolitical play into the cosmos carries the shadow of our terrestrial history into the stars. As nations and possibly corporations stake their claims to lunar minerals or strategic orbital slots, tensions likely will escalate under the timeless pressures of scarcity and competition. The galactic battlefield, once the subject of novels and films, could become a stark reality, raising pressing questions about the governance of space, the rights of colonists, and the containment of conflicts born from Earth's geopolitical chessboard. As we digest the staggering implications of these technologies, we hover on the precipitability to shift the cosmos itself. From theory to terrifying potential, space warfare, studded with its kinetic rods, antimatter arsenal, and laser precision, floats on the horizon of tomorrow, compelling us to ponder not just the mechanics of combat, but the blueprint of cosmic coexistence. So, as we turn our eyes towards the stars, let's consider not just the wars we might wage, but the peace we hope to preserve. Knowing well that every choice, every innovation, shapes not just the future of warfare, but the future of humanity itself. From battlegrounds in the void to the moral and ethical quandaries amid the stars, our journey is just beginning. What role will we play as stewards of the cosmos? The universe awaits our answer.